So systems part one. A system is when you have two equations, and an x and a y, two or more equations. There are systems of three equations and three variables, but we're doing systems of linear equations and two variables. So we've got an x and a y. Sometimes you see a system like this where it's already both solved for y, and sometimes students want to change it into this form because they're more used to it, but think about it. In this one here, you're saying that y is this and y is also this, so they must be the same. Half x plus 2 is negative 3x minus 5. Multiply both sides by 2. You eliminate that fraction, one way to do it. X plus 4 is negative 6x minus 10. So we'd add the 6x to each side, so 7x, subtract the 4, and x is negative 2. Now, when you're solving a system, you're coming up with one ordered pair that makes both true, so we need a y. So go back up here. So y is half of negative 2 plus 2. Negative 1 plus 2 are 1. So y is 1. So you have negative 2, comma 1. Now when I'm doing it, I always go and check and make sure that one makes the second equation true. Is 1 negative 3 times negative 2 minus 5? 6 minus 5? Yeah, it is. And so that one checks out. Another way you could have solved this one is graphically. That means just put them both on a graph. This has a y-intercept of 2, a slope of up 1 and to the right 2. So there's your line. Y-intercept of negative 5. Your slope is down 3 to the right 1. And you'll find that those two lines intersect at negative 2, 1. This one here, they're in standard form, not slope-intercept form. But what you notice is you have some coefficients of 1. If you have a coefficient of 1 anywhere, you can solve for that variable and use what's called substitution. So I'm going to solve this first one for x. So x would be negative 1 minus 2y. And I always put in parentheses. And you're going to substitute that. Instead of writing x here, you're going to put negative 1 minus 2y. So we get negative 1 minus 3y is 8. Add a 1 to each side. Divide by that negative 3, and there's your y. And you can go right back up here. X is negative 1 minus 2 times negative 3, negative 1 plus 6, which is 5. So 5, negative 3. And again, let's just check and make sure that's true. 5 minus a negative 3 would be 8. So they both check. 5 plus negative 6 is negative 1. This last one here, when you see it, you don't have any coefficient of 1. So we use what's called elimination. Linear combination is another name. Your goal is to get either the x's or the y's to cancel out. Lots of different ways you can do it. I'm going to choose to eliminate the x's. So 3 and 2, they meet at 6. So I need a positive 6 and a negative 6. So if I multiply this one by negative 2 and this one by 3, I'll get that. I could have multiplied this one by positive 2 and this one by negative 3. If I wanted to eliminate y, you know 4 and 3 meet at 12. So I would need a 3 here and a 4. And one of them has to be negative to eliminate that. So I'll go ahead and do that multiplication. I put the number on this side so that I make sure when I'm multiplying that I multiply this constant over here by the negative 2. Okay, so then we get y equals 1. So then we would do 3x plus 4 times 1 equals 10. 3x equals 6, so x is 2. We come out with 2, 1. Again, check that in here. 4, 2 times 2, 4, plus 3 times 1, 3. 4 plus 3 is 7. That checks. But if I had done it in a different style, if I had multiplied by through, let's say I multiplied this one by positive 3, 9x plus 12y equals 30, and this one by negative 4, negative 8x minus 12y equals negative 28, I would have come out with 1x equals 2, and x is 2, which it was, and then get the y. So again, your goal is you're trying to get either the x's or the y's to cancel out completely. So you want to see where do these numbers meet. Always check first to see if does 3 go into 2 or 2 go into 3, and then you just need to multiply one equation. Now there's a couple of twists in this when you get all the variables to drop out. So that's in the one called Systems Part 2.